Hey guys, today we're going to take a look at balancing chemical equations. So I have chosen 3 equations for us to go through. They each are a little bit different from each other. So to start off, when balancing chemical equations, we need a method to use. So the way I like to do it is I look at all the different elements in the equation. So for example, if we take a look at A, we have phosphorus, which is our P, and we have oxygen, which is our O. And then I'm going to figure out how many phosphorus are on the left side and how many are on the right side. What we can do is we can look over here and we see P4. And just make sure you check the whole left side because they can be in more than one spot. So on the left side, we have 4 phosphorus. And then if we come and we look on the right side, we currently have 2. So if we write that down, this will help us keep track of how many we have once we start changing it. And now for our oxygens, we can see on the left side we have 2, and on the right side we have 5. Now I would take a look and we need to try to balance it. So the first thing we'll notice is we have 4 phosphorus on the left and 2 on the right. So if we need to get to the 2 to a 4, we can double the number of phosphorus there were. And to do this, we have to put a 2 in front of PTO5. And we have to consider, well, what did I just change? I changed the number of phosphorus on the left side and oxygen. So now I actually have 4 phosphorus, and I get that by doing 2 times the 2 I had. And now I do the same thing for the oxygen. So I had 2 times the 5 I had. So now I have 10. Okay, so now we'll notice that we have 10 oxygen on the right side and only 2 on the left side. And going back to our left side, if I need to get 10 oxygens, what I can do is put a 5 in front of this oxygen here. Just like that. And the only thing that 5 affected was the oxygen. So I can erase the 2 and now I have 10. Just double check. I now have 4 and 4 phosphorus and 10 and 10 oxygen. And so if we're taking a look at what type of reaction this is, we'll notice that 2 different elements are coming together to form a compound, which tells us that it's synthesis. Okay, so next up, we're going to take a look at one that only has 3 different elements. It has carbon, hydrogen, and oxygen. But what we will notice is in some of the compounds, we have the same element. So on the right side, we have oxygen in both the water and the carbon dioxide. So let's do the same thing. We're going to say how many of each element are on the left and how many are on the right. So looking at the left side, we'll notice carbons, we have 6 carbons right now. And on the right side, we only have 1. So we have 6 and 1 on the right. And then hydrogens, we have 12 right now on the left side and 2 on the right side. And then last but not least, our oxygens, we only have 2 on the left side. And what we have to be careful about here is we have 2 oxygens here, but we also have 1 here. So we have a total of 3 on the right side. Okay, so when we have a reaction that only consists of carbon, hydrogen, and oxygen, we're looking at a combustion reaction. And often with our combustion reactions, you'll see water and carbon dioxide being produced. The rule I like to follow when balancing a combustion reaction is always start with the carbons, then balance the hydrogens, then balance the oxygens. This is going to make your life much easier, and you'll be more likely to get the right answer than if you jump back and forth between them. So we'd start off with our carbons. Right now we have 6 on the left, and we only have 1 on the right. So I need to get that 1 to a 6. So to do that, I have to put a 6 in front of our CO2. I now have 6 carbons on the right, but I also affected the number of oxygen I have. So I have 6 here. And if we take a look at how many oxygen we have now, we have 12 and one more, so 13 oxygens. Okay, so now I actually have to go down to hydrogen. And so now that my carbons are balanced, we're going to try to balance our hydrogen. So on the left side, we currently have 12, and on the right side, we have 2. So I need to get this 2 to be 12. And to do that, I'm going to put a 6 in front of it. So now I've affected the number of hydrogens I have, and also again the number of oxygens I have. So I now have 12 hydrogens. And if we count up how many oxygen we have 12 here, and we have 6 here. So in total, we have 18. So now that our C and our H are all balanced, we can move on to our oxygen. On the right side, we have 18, and on the left side, we have 2. So we need to try to balance that. But another thing to consider is if I have a situation where this is all I have left to balance, say oxygen is in more than one location, you always want to try to use the one where oxygen is by itself, because then we won't mess up our carbon or our hydrogen again. So right now we have 2. And what number can I put in front of here for me to get 18? I'd have to put a 9. So then I'd have 18 oxygen on the left and 18 on the right. So this one is now balanced. All right, our last one is a little bit different because now we have a polyatomic ion in our reaction. This is what we see here is our PO4 as well as our SO4. So when I have to balance something with a polyatomic ion, first I need to consider, did that polyatomic ion break up into the individual components, or did it remain a polyatomic ion? In this case, we notice the PO4 on the left actually stays PO4. And then our SO4 actually is SO4 on both sides. The reason we consider this is because if I have, say, an SO4, and on the other side of the reaction, I might have an SO2, and maybe I have just another oxygen, I broke apart the SO4, so I have to consider all the parts separately. So in this case, instead of considering this PO4 as phosphorus and oxygen, when I make my list, I'm going to have a sodium, I'm going to have PO4, I'm going to have calcium, and I'm going to have SO4. So now we can go about balancing it. So let's see. On the left side, for sodium, we currently have 3, and on the right side, we have 2. For PO4, on the left side, we have 1. The way we know it's 1 is because if there's more than 1, PO4 would be in brackets with a number down here. So we have 1 on the left side, and then on the right side, we notice PO4 is in brackets, and there's 2 PO4s. Take a look at calcium. On this side, we have 1, and on this side, we have 3. And then finally, for our SO4s, we have 1, and then we have 1. All right, so let's start off by trying to balance our sodium. So what we'll notice is our sodiums on the right side are always going to be coming in sets of 2 because we have NO2. And on this side, we have NO3. So if I need to get these to match, I almost have to think of it like a lowest common denominator. There's no way I could get the right side to become 3. So I'm going to get them both to become 6. So to do that, we're going to have to put a 2 in front of Na3PO4 and a 3 in front of Na2SO4. So now I have 6 and 6. But what I do need to consider is I just changed the number of phosphates and the number of sulfates I have. So if we take a look at the number of phosphates on the left side, we now have 2. And if we look at our sulfates, we now have 3 on the right side. So we can change that in our table. And then the last thing that we need to do is we balanced our PO4s. We need to take a look at our calcium. Right now we have 1 on the left and 3 on the right. So we have to put a 3 in front of here. And that's going to change the number of calcium and the number of sulfates. So now on the left we have 3 calcium and we have 3 sulfate. And now taking a look at our overall table, everything is balanced. Now if we just take a look at what type of reaction this is, we'll notice that we had 2 things switching out with each other. The sodium swapped places with the calcium to end up with the sodium in the sulfate and the calcium in the phosphate. So this was a double displacement reaction. Hopefully that clears up some of the questions about balancing chemical equations. So just go through it slowly. You can always double check and recount each side as you go, or maybe at the end. And I hope good luck on your chemistry. Feel free to subscribe below.